Alright, hello guys. So today we're going to calculate wave velocity. Title it up, wave velocity example problem 1. Write down the question, alright, the equation, a list where you could fill in for givens, information that you get from reading the problem, and then we're going to do a calculation together. So hit pause, write it down, and then we'll start. Alright. So we've written it down, and let's read the question and fill in our list of givens as we read the question. Okay, we're going to be using our standing wave equation, Fn equals nv over 2L. Okay, so this n on the left side of the equal sign does not mean f times n. Fn is one variable that is represented by two letters, okay? So it could be F1, that means it's the frequency for the first harmonic, F2, n can be 2, and that means it's the frequency for the second harmonic, and so on and so forth. So let's read the question and fill in our list so we know what to plug in the equation, all right? It says, calculate the velocity of a wave through a violin string of length 0.2 meters, okay? So 0.2 meters, we're going to fill that in for L in our list. The string's fundamental frequency, so we're going to underline that as well, because that gives us a piece of information. What frequency do we refer to as the fundamental frequency? Is it the frequency for the first harmonic, the second harmonic, the third harmonic, the fourth? Because it's fundamental, it's the frequency for the first harmonic. So in our list, we're going to write down F1, put a 1 next to that F, meaning frequency for the first harmonic, is, it says, 800 hertz. And because we made n1 over here, we're going to write down n equals 1. And we're calculating wave velocity, so we could put a question mark next to the v, alright? Now we can do our calculation. I'm not going to rewrite the equation just due to space, but we're going to fill it in, okay? So, where it says Fn, we could write F1. That's 800 equals, on the top of the fraction is n times v, so that's 1 times v. We're not going to fill in a number for the v, that's what we're trying to calculate. And on the bottom of the fraction, 2 times L. And L, we're going to fill in a number from our list, is 0.2 meters, okay? So then we're going to go ahead and calculate v, alright? So the way we're going to do that is we're going to put 800 over 1, and then we're going to cross multiply. So we circle diagonally this way, and diagonally this way, alright? And whatever is inside the circle with the other thing, inside that same circle, gets multiplied by each other. So we get 800 times 2 times 0.2 is this circle, equals the other circle, 1 times 1 times v, alright, which is just v, alright. If you multiply something by 1, you don't have to write the 1, okay. So, alright, 800 times 2 times 0.2, we could do that on our calculator, and then we have the velocity, and that'll be, when you do it, I could do it right here, and you could try it right now as well. The velocity comes out to 320 meters per second. Alright. Now let's do one more problem where we calculate wave velocity, and I'll throw a little bit of a twist at you. Okay? So I'll flip the board, and you can write down wave velocity example problem 2, and write down that we're going to use the same information as number 1, except make 2 changes. We're going to change the harmonic to 2, alright? So that means that n equals 2. And we're going to change the frequency, because it's the second harmonic, it has to have double the frequency, which is going to be 1600 hertz. And we're going to go ahead, I just want you to know how to do the same thing as last time, is to calculate v, but this time, how are you going to calculate v when n is 2? which reminds me that if n is 2, we should write F2 for the second harmonic equals 1600 hertz. Okay? And L, we're going to keep the same as 0.2 meters because it's the same string as the last problem. Pause the video right now and copy down what you see on the screen, and then we can start again. Okay, so let's do the calculation. Where it says Fn, I'm going to write what F2 is. The number is 1600. So that's on the left side of the equal sign. Alright, the top of the fraction is n times v. Alright, so this time n is 2, because we're in the second harmonic. And v, we don't know what it is. That's what we're trying to calculate, just like the last problem. On the bottom of the fraction still is 2 times L. Alright, so 2 and L is still 0.2 meters. So remember the point of this, how do we calculate wave velocity if it's the second harmonic now? It ends up being a little bit, there's one more step to the calculation. You still have to start by putting the frequency, 1600, over 1, so that you can cross multiply next. Circle on the diagonal, and whatever's in the circle with it gets multiplied by each other. So 1600 times 2 times 0.2 equals 1 times 2 times v. So 1 times 2 is just 2, and then you could write v. So you see, you could multiply in your calculator 1600 times 2 times 0.2. Do it with me. That's 640. You might say to yourself, oh, the wave speed is more now that we're in the second harmonic, but there's one more step. Don't forget, when you're in the second harmonic, there's a 2 next to the V at the end. Last time there was just a 1 there, so you didn't have to do any more steps. You were done. This time, there's a 2 still left over, so you have to divide both sides by 2, and you're left with just V on the right side, so you're done once you do 640 over 2. Do on your calculator 640 over 2, and you're going to see that the wave velocity, even if you're in the different harmonic, but you're on the same string, is still 320 meters per second. The wave velocity does not change if you go to another harmonic, because you get a bigger frequency, but there's a 2 on the other side too. Alright? So switching harmonics doesn't change the wave velocity. The only thing that changes the wave velocity is the tension of the string.